Standard 12 Maths Chapter 2 Complex Numbers Exercise 2.4 Question number 1. Write the following in the rectangular form. So given 5 plus 9i plus 2 minus 4i the whole bar. You have to simplify and give in the rectangular form, that is given the standard form. Real part and imaginary part you have to give. So this is equal to, I can write as, according to the rule of this complex number, z1 plus z2 the whole bar can be rewrite as z1 bar plus z2 bar. So I write here 5 plus 9i whole bar plus 2 minus 4i the whole bar. So the conjugate of 5 plus 9i is 5 minus 9i. Conjugate of 2 minus 4i is 2 plus 4i. What is 5 plus 2? 7 minus 9i plus 4i is minus 5i. So this is the standard form of this representing the complex number, or we say it is in the rectangular form. Real part and imaginary part. See the second sum. 10 minus 5i by 6 plus 2i. So it's a fraction here. So what I do, take the denominator complex number 6 plus 2i. So the conjugate of this 6 plus 2i is 6 minus 2i divided by 6 minus 2i. You multiply numerator and denominator by conjugate of the denominator term, 6 minus 2i. See, look at the denominator term. This is a plus ib into a minus ib. So, the formula actually a plus b into a minus b is a square minus b square. A square minus ib the whole square. But I squared is minus 1. So, minus of minus, this is plus. A square plus b square. A is here 6 squared plus 2 square. So, and then simplify the numerator term here. 10 6 are 60. With 6 I multiply both the number. Minus 30i. Minus 20i. Minus into minus plus I squared minus 1. Minus 5 2s are 10. 6 squared is 36 plus 4 is 40. Denominator 40, and real part here 60 minus 10 is 50 minus 50i. 30i minus 20i is 50i. So take 50 common outside. So you will get 1 minus I. Denominator here 40. So 10 goes here 5 times. 5 by 4 into 1 minus I. This is the rectangular form. Third sum. 3i bar plus 1 by 2 minus I. So first you take the conjugate of this 3i. So conjugate of this 3i is minus 3i. Conjugate we change the sign for only the real part. Minus 3i plus 1 by 2 minus I. I multiply the conjugate of this denominator term. So 2 plus I by 2 plus I. So this is equal to minus 3i plus 2 plus I by a square plus b square. 2 square plus 1 square. So minus 3i plus 2 plus I by 5. 2 square 4 plus 1 5. See, minus 3i plus, you keep separate the real part, 2 by 5 plus I by 5. Simplify the imaginary one, minus 3i plus I by 5. Take 5 as LCM, minus 15i plus I. So minus 14i by 5. So 2 by 5 real part minus 14 by 5i. So this is the standard form of the complex number, or we say in the rectangular form. See the second sum. If z equal to x plus iy, find the following in rectangular form. Real of 1 by z. Real of 1 by z. Actually, real of 1 by z is 1 by x plus iy. Z is x plus iy. So, real of, take the conjugate of this x plus iy on both sides. So, that is x minus iy by x minus iy. This is equal to real of x minus iy by a plus b into a minus b, a squared, iy squared, that is plus y squared. So we need only the real part. So real of the numerator is x, by denominator is fully real part. So take real of x square plus y squared, or we say that real of iy by x square plus y square. So this is the standard form of the complex number. I take only the real part. Real part is here x by x square plus y square. This is the answer. Second one, real of I z bar. That is real of I z bar is x plus iy the whole bar. That is real of I into, what is the conjugate of x plus iy? X minus iy. So multiply with I this number, xi minus I into I squared is minus 1. So plus y. So from this you collect only the real part. Real part is y here. Third sum, imaginary of 3z plus 4z bar minus 4i. This is equal to imaginary of 3z is x plus iy plus 4 into z bar is x minus iy minus 4i. So imaginary of 3x plus 3iy plus 4x minus 4iy minus 4i. Just I remove the bracket here. I multiply with 4. So imaginary of, collect the real part, 3x plus 4x is here 7x. And see the imaginary one, 3iy minus 4iy is, you will get just same similar terms. So here you will get minus iy one time, iy minus 4i. So imaginary of 7x minus I into y plus 4. Y plus 4. So I need only the imaginary part of this. So imaginary part is here y plus 4 minus y plus 4. So minus y plus 4. This is the answer. If z1 is 2 minus I and z2 is minus 4 plus 3i, find the inverse of z1, z2 and z1 by z2. So what do you mean by inverse of? You have to find first one, inverse of z1, z2 is 1 by z1, z2. This is inverse. Second one, inverse of z1 by z2 is reciprocal. So just 1 by, instead of writing that 1 by, I write z2 by z1. So first sum, I find first z1, z2. So Z1, Z2. Z1 is 2 minus I. Z2 is minus 4 plus 3I. Simplify this. First multiply with real part the whole of this complex number. Minus 4 2s are 8. Minus minus plus 4I. 3 2s are 6, 6I. I squared is minus 1, minus minus plus 3. So this is equal to minus 5 plus 10I. We need to find 1 by Z1, Z2 to find 1 by. So that is 1 by minus 5 plus 10I. So reciprocal. Take the conjugate of this. Minus 5. For conjugate you have to change the sign of only the imaginary part. Plus 10I. So I take minus 10I. Minus 5 minus 10I. So minus 5 minus 10I divided by minus 5 squared plus 10 squared. A square plus B squared. Minus 5 minus 10I divided by 25 plus 100. That is minus 5. You can take it as common. So 1 minus I have taken outside 5. So 1 plus 2I divided by 125. See, you have to find Z1 by Z2. So 2 minus I by minus 4 plus 3I. So to find the reciprocal of this, that is already I shown you. So 1 by. So 1 by Z1 by Z2, that is equal to the reciprocal Z2 by Z1. Just find the reciprocal. Z2 is minus 4 plus 3I by 2 minus I. Take the conjugate of this 2 minus I. So 2 plus I by 2 plus I. So denominator A square plus B square. 2 square plus 1 square. And then here numerator minus 8 plus 6I minus 4I. I squared is minus 1 minus 3. So minus 11 plus 2I by 5. So 1 by 5 minus 11 plus 2I. This is the answer. Thank you.